Hello students, welcome to my channel. In this class I am going to teach you harmonic function, harmonic conjugate, and we will solve some problems. Let us start the topic. Our first question is find the conditions for which u of x y which is equal to the power alpha x cos beta y is harmonic. So here u is equal to e to the power alpha x cos beta y, then del u by del x is equal to alpha e to the power alpha x cos beta y. Del square u by del x square is equal to alpha square e to the power alpha x cos beta y. Del u by del y is equal to minus beta e to the power alpha x sin beta y. Del square u by del y square is equal to minus beta square e to the power alpha x cos beta y. So we are getting the partial derivatives del u by del x, del u by del square u by del x square, del u by del y, del square u by del y square. Now u is a harmonic function. So this implies del square u by del x square plus del square u by del y square is equal to 0. So this gives us alpha square e to the power alpha x cos beta y minus beta square e to the power alpha x cos beta y is equal to 0. So this implies alpha square minus beta square e to the power alpha x cos beta y is equal to 0, from which we get alpha square minus beta square is equal to 0. This implies alpha square is equal to beta square, alpha is equal to plus minus beta. So the function is harmonic if del square u by del x square, del square u by del y square is equal to 0. And we are putting the values of del square u by del x square, del square u by del y square, and by making 0 we are getting alpha is equal to plus minus beta, which is the required condition, So we are getting the condition. Now our first problem is solved. Let us proceed to solve the second problem. Now our second question is, let a dash of z is equal to 0 for all z belongs to D, where f of z is analytic for all z belongs to D, where D is the domain of the function. Prove that f of z is equal to constant. Given f of z is analytic, let f of z is equal to u plus iv. Then f dash of z is equal to ux I vx. But f dash of z is equal to 0, it is given. So as it is given, this implies ux is equal to 0, bx is equal to 0. Then its conjugate parts also 0. this implies uy is equal to 0, vy is equal to 0. So ux is equal to uy is equal to 0. This implies u is equal to constant is equal to C1 say. Uy is equal to Vy is equal to 0. So this implies V equals to constant. So V is also constant. Let it be 0. Hence, f of z is equal to u plus iv is equal to c1 plus I.SC is a constant. So we get f of z is equal to constant. So proved. So we proved the second problem. So the second problem is now proved. Let us proceed for the third problem. Our third question is prove that u is equal to xq minus 3xy square is a harmonic. Find its harmonic conjugate. Find its harmonic conjugate. Also find the corresponding function f of z. Proof. Given u is equal to xq minus 3xy square. Del u by del x is equal to 3x square minus 3y square. Del square u by del x square is equal to 6x. So we are getting del u by del x, del square u by del x square. Del u by del y is equal to 6x y, 6xy minus 6xy. Del square u by del y square is equal to minus 6x. Then del square u by del x square, del square u by del y square is equal to 6x minus 6x is equal to 0. Implies u is harmonic. So the function u is a harmonic. Now we have proved the function u of xy is a harmonic. To find its a harmonic conjugate, to find harmonic conjugate V, harmonic conjugate for u. To find harmonic conjugate for u, let V be the harmonic conjugate of u. We have the V is equal to del V by del x dx, del V by del y dy. And we know del u by del x is equal to del V by del y. Del u by del y is equal to minus del V by del x. And this is CR conditions we know. So this equals to this del v by del x is minus del u by del y dx. Del v by del y is del u by del x into dy. So now minus del u by del y minus del u. So it will be 6xy minus dx plus del u by del x is 3x square minus 3y square dy. So this is equals to 6xy dx plus 3x square dy minus 3y square dy. And this is equals to derivative of 3x square y minus 3y square dy. So now integrating we get v is equal to 3x square y minus y cube plus c. So integrating both sides we get v is equal to 3x square y minus y cube plus c, which is the required harmonic conjugate of u. So we are getting harmonic conjugate of u. Now to find the function f of z, to find the function f of z, we have f of z is equal to u plus I. F of z is equal to u plus I. This is x cube minus 3xy square I. V is 3x square y minus y cube plus c. So this is equals to x cube minus 3xy square 3ix square y cube iy cube plus ic. So this is x plus iy whole cube plus ic. This is z cube plus ic. So we can write this is equal to z cube plus c dash, where c dash is equal to ic. So we get the corresponding function f of z, and with this the problem is solved. The topic for today class is completed. In my next class I shall meet you with a new topic. Till then, goodbye.